In this video, we're going to discuss how we can get more consistent gains through Xylanase application. This is going to look at three potential different mechanisms that the Xylanase can act in terms of improving animal performance. And what we will look at is the performance improvement, particularly in swine, and how in the future we can use Xylanases to optimize animal performance. So why do we want to use Xylanases? If you look at the NSP contents of different feedstuffs, we can see from this visual that if you look at the corn, the wheat and the barley, that the Arabinoxylan contents are the highest NSPs in these particular cereals. Therefore, if you look at the diets for a corn soy diet or a wheat soy diet, the composition of that NSP content will be around about 40 to 50% of Arabinoxylans. There are two components of the Arabinoxylans. There's the soluble component and the insoluble component. The soluble component has an effect by increasing the viscosity of the digester in the upper tract, and this can have a negative impact on nutrient digestibility and utilization. The insoluble Arabinoxylans form a part of the structure of the plant cell wall, and therefore this impedes the endogenous enzymes of the animal from breaking down the starch and protein within that plant cell wall. So therefore, if we can use a Xylanase, we can reduce the viscosity and therefore improve digestibility, or we can break down and punch holes in the cell wall, giving access to the starch and protein to the pigs or the chicken's own endogenous enzymes. Xylanases are three main mechanisms. The first mechanism is the ability of the Xylanase to reduce the digestive viscosity. Typically, a soluble Arabinoxylan will increase the digestive viscosity. This impedes nutrient utilization by the animal. If we add a Xylanase, we break down the long-chain Arabinoxylans and therefore reduce the digestive viscosity. This improves nutrient utilization, especially related to fat and specifically saturated fats. The second mechanism is the ability of the Xylanase to break down the insoluble Arabinoxylans in the cell wall. Effectively, it's punching holes in the cell wall, allowing the endogenous enzymes of the own animal to break down starch and protein within that plant cell wall. And finally, which we're going to concentrate on in the rest of the video, is the ability to produce prebiotic xylo-oligomers through the breakdown of long-chain Arabinoxylans through the use of a Xylanase. So we're going to talk in more detail about the third mechanism, the prebiotic effect of the Arabinoxylan oligosaccharide, or otherwise, as we go forward, Axos. If you look at the top left under the screen, and we go through this in a clockwise motion, you can see that in the top left, visual 1, the long-chain Arabinoxylan is broken down by the Xylanase into small-chain xylo-oligomers. These xylo-oligomers are then fermented by the microflora in the lower and hindgut of the animal, and this can have a multitude of effects. It can have an improvement or increase in volatile fatty acids. These volatile fatty acids can be used as an energy source. They can also be used as bacterial control, or they can also be used for the production of butyrate, improving epithelial integrity. This change in microflora can also have a beneficial by reducing the pathogenic bacteria within the hindgut. And finally, the VFA production has a feedback loop which reduces the digestive flow within the animal. This means that you get greater retention within the stomach and increased overall diet digestibility. If you look at the Axos production, what we can see from this following visual is that not all Xylanases can produce the right Axos profile or the same Axos profile. This can be determined by the dose of the Xylanase or the characteristic of the Xylanase. In this graph, what we can see is that there are different profiles of Axos with 4 different Xylanases. At the bottom of the graph, what you can see is X1 to X7, and that gives you the chain length of the particular xylo-oligomer. So X7 has got 7 links, and X1 is effectively xylose. If you look at the enzymes 2, 3 and 4, you can see that predominantly they're producing an X4 and X5 terms of length chains of xylo-oligomers. However, if you look at the enzyme 1, you see there is a high concentration of xylose. We do know that xylose can be negative to the animal, and it's not something that we generally want to produce in terms of improving production efficiencies and animal performance. How do we know that xylo-oligomers produced by Xylanase can have an impact on the animal? This following trial was conducted by Cortan, and what it shows is that xylo-oligomers produced by incubating wheat bran with a Xylanase can improve broiler performance. If you look at the left hand side of the graph, the dark blue bar, you can see that the feed conversion is around about 1.48 to 1.49. As we then take in these xylo-oligomers and add it to a wheat-based diet, adding it at 0.03%, 0.06%, 0.12%, 0.25% and 0.5%, we do see an improvement whereby it's significant at the 0.5% level. So we're seeing an improvement in feed conversion through adding xylo-oligomers to the diet. But the classic thing within this experiment is that they also added the Xylanase that was used to produce the xylo-oligomers externally actually to the animal and get a similar level of performance to the 0.5% xylo-oligomers added to the diet. This indicates that the mechanism of Xylanase producing xylo-oligomers is indicative of improved performance within the animal. If you look at the mechanism of xylo-oligomers, one of the key components was the production of volatile fatty acids. In this following graph or visual, what you can see is we did a trial conducted in weaned to finished pigs looking at the impact of adding a Xylanase to a corn soy distillers based ration. The addition of the Xylanase in the dark blue bars showed an increase in the fecal acetic acid content by improving it by 20%, the propionic acid by 10%, the butyric acid by 9%, and this resulted in an increase of 22% in the total volatile fatty acid component, which was significant. This data supports the mechanism that we discussed, where xylo-oligomers increase the volatile fatty acid production within the animal. This is especially important in pigs, where the older pig can utilise volatile fatty acids for energy and improvement in feed efficiency. The following slide is a combination of pig and poultry work, looking at the impact of Xylanase on improvement in the undigested fraction of amino acids. If you look on the left hand side, threonine has an undigested fraction of around about 0.24 to 0.26. The undigested fraction can be defined by looking at the total threonine minus the digestible threonine. If you then look at methionine, methionine is often added to the diet as a synthetic amino acid, and so therefore the digestibility of methionine in the diet is higher. So if you look at the undigested fraction of methionine, you find that the undigested fraction is around about 0.1 to 0.12. However, when you look at the improvement in digestibility of that undigested fraction for threonine, which can be depicted by the red line, it's around about 15%. And also for methionine, it's 15%. And in effect, all the amino acids are improved by the Xylanase by 15%. And this shows that you have a mass action effect of a Xylanase on the diet. This helps support the mechanism whereby you are producing the volatile fatty acids, slowing down that digester and improving overall feed digestibility. We've talked about the mechanistic effects of the Xylanase, but what happens when we feed a Xylanase to the animal? This is a trial that was conducted in the US in finisher pigs, fed corn, soy and distillers. In the trial, the pigs were either fed the control diet or the control diet plus the Xylanase from day 20 to day 146, or in effect slaughter. What you can see is that from day 20 to day 83, the dark blue bars, which are the performance of the pigs fed the Xylanase, you see a small improvement in feed conversion. From day 83 to day 146, or around about the start of 60 kilos, you can see quite a large impact on the Xylanase in terms of feed conversion ratio. This helps support the mechanism Because what we believe may be happening in this particular case is that we are seeing an increase in the volatile fatty acids that we had discussed previously, and that the pig can start to utilize those volatile fatty acids as an energy source, which then results in this dramatic effect on feed conversion ratio. The previous study has shown that the addition of Xylanase in the nursery improves overall feed conversion, but with the bigger response being in the late finisher pig. We believe that this may be a way that we can get greater consistency of response, particularly in corn, soy, distiller-based rations. The following graph is a 5-trial summary in the US based on corn, soy, distiller rations where Xylanase was added into the feed during the nursery period. What you can see from this slide is that there is a 6-point improvement with the addition of a Xylanase. And this 6 points is worth approximately, based on the US system, about $1.80 to $2.10 per pig. So we've gone through the mechanism of how a Xylanase can work. We've also gone through how the Xylanase can impact particularly pig performance. So how do we ensure we get a consistent response with the Xylanase? We need to select the right Xylanase. It's important that when we add the Xylanase to the diet, it actually gets to the animal and can be consumed through the feed. So therefore, thermostability is important. It needs to be able to get through the processing temperature within the mill. Assayability is also key. We need to know that the Xylanase is there, and some Xylanases can be affected by serial inhibitors, therefore reducing the ability to detect the Xylanase within the feed, even though it may well be there. It also has to be active in the gut. It needs to be pepsin and acid stable, so therefore it can have effect within the animal. Another key component, which we've already discussed, is the mode of action. We need to be able to produce the right profile of xylo oligomers. We don't want to produce a high level of xylose, we want to produce the right profile. We also want to be able to reduce viscosity and also open up feed cell walls. One other key component is that we need to feed the Xylanase early for the maximum returns. What we found in these studies is that when we feed the Xylanase in the nursery period, we can have a dramatic improvement in feed conversion in late finisher. This can reduce substantially the amount of feed intake within the finisher pig and produce considerable cost savings. Thank you.